this next question has to do with how do we do events in any logic? So it turns out that any logic is event-based, okay? And it turns out any logic supports system dynamics model, and Agent-based modeling supports a discrete event model and hybrids of them, which makes it quite interesting. But in terms of events, there's actually a thing called an event, okay? So the whole thing is built atop of events. Any logic goes event to event to event to event. However finely it needs to simulate things in time, it does so, okay? So if something's going to happen really, really, really quickly, it simulates as fast as needed. If it's going to happen only occasionally, it'll hop between those occasional times, okay? So you have to realize that when we looked at person, for example, it's events that are occurring here. Like this infection was triggered by a message being received by this person. This person got a message from a neighbor saying, you were exposed to this illness. And that was an event that took place, okay? Here's another event, the recovery event. This recovery is taking place. It's a instantaneous sort of event which happens after some time. And you'll notice this rate here. This rate, ladies and gentlemen, we've seen that before. Just like a first order delay. There's some chance per unit time. What's that? Yeah. That's right. Exactly. It's exactly the same thing. It's chance per unit time here that a given person will go from here to here. So, ladies and gentlemen, if that chance per unit time is 1%, 0.01, how long do they spend here on average? We saw it with first order delays. If you have a chance per unit time of 0.01 of leaving a stock, how long do you spend in the stock? 100 years, 1 or 100, whatever. 1 over 0.01. So it's the same thing. It's the same basic logic. These are events, though. So this is not, these transitions, remember they're at the individual level. This is not a count of people who are going here. This is for this particular person, what's their particular chance per unit time, and they go in an instant. It's an event. It's an instantaneous event. Now, the whole of any logic runs atop these events. That is its lifeblood, its pulse, as it were. It's not an irregular pulse. It's a pulse that occurs sometimes frequently, sometimes less frequently, but it's associated with these transitions. These events are what drives it. And we have in any logic an explicit construct called an event. And in fact, there's two of them. One's called a dynamic event, and another is called an event. And dynamic, we'll be talking about those later, but it's basically an event that you could have many of them created at runtime. Both are dynamic in the sense they run over time. So there's a reporting event here, and what happens here is that we have this reporting event occurring every 7, in this case, days. It's cyclic. After a timeout, it starts at time 0 and it goes every 7 days. And it's an instantaneous thing. At 7 days, this thing wakes up and it says it's time to do whatever you got to do. In this case, it's reporting. And what happens when it's going to report? It's gonna do this thing. It's gonna print out this thing and it's gonna assign this variable to 0. Okay, it's going to assign this variable. And Kurt would probably be able to interpret the purpose of that variable because its name is count accumulated infections in reporting interval. He's teasing me. So here we have an event occurring every so often, and we can define how often it occurs. And as we'll see, there'll be several different things. This is a timeout event. It occurs exactly this amount of time, or we can make it on a rate, a certain chance per unit time of occurring, or we can make it based on a condition. If the number of people who are infected in the population ever reaches 0, we do something. All those are possible things we could associate with these events. But any logic is, at a deep level, event-driven. Events are what it is, the work its job in life is to service events. Those are the jobs it has to do. Each event is a job it has to take care of. And when we run a model here, you may notice that there's these things EPS down at the bottom. If you don't see them, you can go up to here, and you can say what things you want to show. One thing you might want to show, for example, is model time, but also this EPS. This EPS is actually events per second being handled, okay? And so if I run this event, you can see here, run this model, you could see here, these are the number of events per second that it's handling. It's handling something like, well, it varies from time step to time step. But those events that it's handling, what are those? Those are events of one person sending a message to another one saying you're exposed, another person recovering, another person, for example, getting sick from a message being received. So in any logic, those events are what drive the show. It's handling those events. That's the job for which any logic exists. And the any logic scheduler takes care of scheduling them. And in contrast to the situation with Vensim, which typically runs on some fixed time step or nearly fixed time steps, here the events again can be as far away as possible or as quick as possible. Sometimes we may have a punctuated equilibrium situation. We'll have a long period of time with very few events, and then maybe there's a flood. Maybe there's an outbreak. Maybe there's an electrical shortage. And suddenly things happen really, really quickly. And then it switches back to a mode of stasis. You don't have to worry about that. Any logic takes care of that. It'll jump by leaps and bounds when nothing interesting is going on, when it's boring, it doesn't have a lot of work to do, it just goes, a year forward at a time or what have you. But then when things start happening, it may operate at the level of seconds, something like that. Okay, and it's all handled by the event scheduler. At this point, there's that's interesting. There's still the occasional event, and what is this event that's still occurring? The event is a reporting event. It's going off every 7 days, and so it's handling those reporting events. But events are at the heart of any logic, and capturing those instantaneous events here is really very natural, because that's how things are done. We have these events that trigger at some exact point in time. Things happen then, and we don't have to worry about this whole thing with we did in a stock and flow model, kind of making something very concrete happen in an instant of time. Instead, it's a in what would be a continuous flow. Instead, we have something that naturally is kind of has instantaneous things associated with it. Maybe it's setting a variable or changing something, etc. Okay, so that was a great question. Any other questions before we break? Other question? Okay, so I'm going to ask you for next time to learn a little bit more about state charts. State charts. State charts are the language by which